Hey, Christina,
Hey, Susan.
what are we talking about?
Let's talk about range, variance, and standard deviation.
Oh, I
This,
like this.
yeah, this is in 1.4 measures of variation,
Mm-hmm.
which is another one of those characteristics of data in the
Right,
law
right. Because
CD.M.
sorry,
Mm,
it matters where the center is,
hmm
but it also matters how the data spreads out from the center.
hmm Exactly. Yep. Yep. And so, first and foremost, here in the lecture notes, we're going to be using technology, okay, to find these values. There are formulas. There's two formulas here in your notes, but that is really just to highlight the difference between the population parameter and the sample statistic. They're
Yes.
calculated slightly differently. Okay, so we're going to use in StatCrunch stat summary stats columns if we have a list of data, and
Mm-hmm.
then stat summary stats grouped or bin data if we have a frequency distribution, just like we did in the
Yeah, this
Yep.
is just like we did for means.
hmm Yep.
Okay.
Yep. So the simplest measure of variation is the range, which is the difference between the minimum maximum values. Um, that is really sensitive to extreme values,
It
uh,
is.
but it kind of gives you a general idea of the range of the values. Okay. The one
Mm-hmm.
that we're going to use the most here is standard deviation, which measures how spread out the data is from the mean.
Mm-hmm.
Um, the formulas there um, show, for the sample standard deviation, you are dividing by n minus one, your sample size minus one. But that's a slight overestimate of the population standard
It is.
deviation.
Yeah.
Yeah, because in the population standard deviation calculation, you just divide by your population size. Okay.
So in StatCrunch, how are we going to deal with that? How are we going to communicate to StatCrunch whether we're looking, and we're almost always looking for a sample standard deviation.
Almost always, yeah, unless you're specifically told that it's a population data set or a census,
Yes.
you're
Then
going to,
assume
yeah,
sample and assume you're looking for a sample statistic. Yeah.
yeah. If you do have a population data set, then you would use it's called the unadjusted standard deviation in StatCrunch,
And
and
we'll
then
show you where that is in a minute. I mean, we
yeah,
will.
that'll
But
give you the
just know that's what you're looking for is not standard deviation, but unadjusted standard deviation if it's population.
yep, exactly. So variance is used in some statistical formulas, but it's just the square of the standard deviation.
Mhm. And we don't use it very much. We use standard deviation. We don't really use variance very
No,
much.
no, but since it is based on the standard deviation,
Mhm.
just like the standard deviation, if it's for a population, you have to use the unadjusted variance in StatCrunch.
Okay.
Okay, so really, one of the main things that we want to know the standard deviation for is, um, what kind of values can I expect to find in my data set? And we call those the usual values.
Yes.
So our usual values fall within two standard deviations of the mean. Okay. So if I have a data value that is four standard deviations above the mean, that would be unusually high compared to the rest of the data set.
Right. And when we say that it falls within two standard deviations, what we're saying is you're sitting at the mean, you're either two, and most values will be either within this segment of two standard deviations above the mean or two standard deviations below the mean
Right.
in that section. Yeah.
Mhm. Yep. Um, so
How about if it's like negative 2.1? Is that unusual?
so 2.1 standard deviations below the mean
Yeah,
be considered unusual.
because our cutoff is 2.
Yep.
Okay.
Yep. Great. So let's look at some technology here just for finding the standard deviation.
Mm-hmm.
Um, and I will also show you where you can find that unadjusted standard deviation.
Okay.
So if I use this data set here, my data values are 3, 5, 6, 7, and 9. Over in StatCrunch, I've typed those values in. I'm going to go to Stat, Summary Stats, Columns, because it's for a list of data.
Mhm.
And that's actually in variable 1.
Mhm.
And I'm just going to find the standard deviation and the variance. I'll find the variance too. So on this list here, I'll show you, if you scroll down the list,
There it is.
yeah, under the interquartile range, that's where you can find the unadjusted variance and standard deviation if you had a population data set. Okay. So the ones that are listed up here are assumed to be sample statistics.
Yes.
Okay. So there's our standard deviation. And I just put 2.2 and 5.0 because we typically keep one decimal place more than what's in the data.
Yeah. Yeah.
Okay. So standard deviation of 2.2, variance of 5.
I really like this next question because it makes you stop and think about standard deviations in real life.
Yeah. Yeah. So suppose that Samira records the ages of customers at the snack bar on a college campus from 12 to 2 tomorrow, while Mary records the ages of customers at the McDonald's near the highway at the same time. Who will have the larger standard deviation of their ages, Samira or Mary?
Well, I'm picturing the college campus um, and most people being pretty clustered around the same age, you know. And then I'm picturing at McDonald's, there's going to be a spread. There's going to be grandparents taking grandchildren
Yeah.
into McDonald's during those time periods. And so
Yeah.
there's going to be a pretty good spread of ages there.
Yeah. Yeah. So the mean might be pretty similar. The mean might be
Oh,
somewhere
yeah.
in
Yeah.
the low to mid 20s.
Yeah.
But the standard deviation is probably going to be higher at the McDonald's. So
Mhm.
because we're not going to have people who are like, well, we might have some people past retirement age on the college
But we're
campus,
probably not going to have a lot of 2-year-olds.
but we're not going to have, we're not going to have a lot of small children, hardly any small children. Yeah.
Mhm.
Yeah. So those are going to be more spread out from the mean, those ages.
The
Good.
McDonald's one. Yep.
Yeah. Okay. So last question here with a list of data. I'm not going to show you how to get this in summary stats because we just did that with the other one. But let's look at the maximum and minimum usual values. Okay.
Okay.
So if I do put this data in for the fuel economy,
Mhm.
so this is a sample of mid-sized cars, and they have these given fuel efficiencies. The mean is 28.2, which is
And
in
this is
miles.
from summary stats. This is just putting this in column summary stats.
Yep. So 28.2 is the mean. The standard deviation is 12.9. So to
Okay.
get the minimum usual value, I'm going to take that mean minus 2 times the standard deviation, and I get 2.4 for the minimum usual value. That's 2 standard deviations below my mean.
Okay.
Okay. And then the maximum usual value, 28.2 plus 2 times the standard deviation,
Mm-hmm.
and I get 54 for the maximum usual value.
Okay.
Okay. All right. So using that, is the value of 58 miles per gallon unusual? Yes, it is, because it's more than 54. It's more than 2 standard deviations above the mean.
So those red the arrows that you have on that number line that like are from 54 on up, those
Mhm.
are where the unusual values would be.
Yes.
And the usual values would be between that lower arrow and that upper arrow on that number line. Is that what you're saying?
Yes.
Okay. Because
Yep.
they're closer to the mean. So
Uh-huh.
therefore you would expect them.
Yep.
Okay.
Yep. And so the value of 28 miles per gallon, that's actually really close to the mean. So that's not
Yeah.
unusual at all.
Right.
Okay.
So it's not unusual. No.
No. Good. All All right, so the last thing in this section is looking at measures of variation for bend data or frequency distributions is what we'll usually see. Okay.
Right, and this is going to be an estimate
Mhm.
of the standard deviation.
Yeah, just like it was an estimate for the, the mean when we found that. So if I go to stat summary stats grouped bend data, I can get the mean and the standard deviation estimates for this frequency distribution. So I have this table in here. You know what I was just thinking?
What?
I think this is all US presidents. So I should possibly use an adjusted standard deviation.
Yeah,
Because this is a population data set.
it is a population, so we will do unadjusted on this.
Yeah. I don't remember if I did that or not when I.
Well, we're about to find out, aren't we?
We're about to find out. Let's find both. Okay. So, summary stats, grouped or bend data, and I have my bins listed in age, and I have my counts listed in frequency. So let's find the mean and the standard deviation and the unadjusted standard deviation.
Now the mean would
Isn't it
be
going to change?
same. Yeah, the mean won't change between population and sample. So you don't have to worry about an unadjusted mean, but you do have to worry about an unadjusted standard deviation. And which one did Christina use?
I used the sample standard deviation.
Uh-huh.
But looking back at this, I really think that it should be a population standard deviation because it is all of the presidents. So I'm going to change this, okay, to 7.3. Okay.
Lest y'all think we script these things out before we do the videos, you can clearly see that no, we do not.
All right. Yeah. I think it should be 7.3.
Okay.
Because it is all the presidents.
That was a great thing that just happened.
Yeah. That won't happen on your homework. It'll clearly be a sample.
Yeah, you'll know that it was a sample or a population. It won't be vague like this.
Yeah. Yep. I was just thinking about that. Okay.
I love that.
Yep. All right. So last thing here is just another kind of bend data. Going back to the GPA kind of problem.
But sometimes this shows up in the homework, so we want to address something about it.
Yeah, just a reminder that if you needed to find the mean and standard deviation for, something like this with letter grades, to change those to numerical values, and then you can use StatCrunch.
So A's are worth 4 points in the GPA calculations, and B's are worth 3. So we just changed those numbers.
Yep.
Okay.
All right. I think that's it.
Okay, good deal. See you next time.
Bye.